I'm going to go ahead and open LabView again. And I'm going to go to File and open my old VI that I saved for the previous version. So I just navigate to it, and it'll show up my front panel. Now, only the front panel sometimes shows up when you hit File Open or open an old VI. The shortcut to show the block diagram is Control-E, and you notice the block diagram shows up. Now, if I hit Run, I should see my data. I do. Now, keep in mind that when you save the file and you go open this on another computer and you have the DAQ assistant already inputted, that DAQ assistant is only valid for that specific DAQ, for that specific computer, for that specific USB port. So I use the same DAQ on the same computer, but I use a different USB port. I'll have to delete that DAQ assistant and put it in again because it'll give you an error. So the best practice is to make your lab VIs outside of the lab and then insert the DAQ assistant when you get to the lab, and then just connect your data output to your rest of your VI. So again, keep in mind that when you have a different computer and a different DAQ, or the same computer and the same DAQ but a different USB port, the DAQ assistant will not work. It will give you an error. And I can show you that error really quickly. I'm going to switch my USB port for my DAQ and click Run, and I tried to run, but you notice, see, I get this error. And that's because I hooked the DAQ into a different USB port and it's not referenced the proper USB port. So I'll hit stop. I'm going to replug it back into that same port as before. It was trying to install the driver for that port, but it hadn't already been installed. And I disconnected it before it can start installing. Now I should be able to hit Run, and it'll run again. So as you notice, even though I'm on the same computer with the same DAQ, I have to use the same exact USB port. So if you want to use the same DAQ assistant, make sure you're getting the same DAQ and that you're getting the same computer and you're getting the same USB port, so you can note that down. And you can note if you're using the same DAQ by looking at the serial number on the bottom of the DAQ, as well as the computer as well. So today we're going to expand on what we previously did, which was insert controls, learn how to use the DAQ assistant, and learn how to create a graph. The next thing we're going to learn how to do is create a mean, and we're going to create the mean of this signal right here, this waveform signal. To do that, you right click on the block diagram, go to Mathematics, go to Probability and Statistics, and you'll find the mean. And you notice it's showing up here. This top one here, it says mean, is the output. This one is the input. So I'm going to select here, click on that little dot, and then I'm going to click somewhere on the wire or on the data or on the waveform graph. It doesn't matter. It's doing the same thing. And you notice that you give a little converter here, because this is like a dynamic signal and this is like an array signal. So it creates like a table for the mean to be calculated. So it needs that. Now to display our mean is a single value. You can go to the mean, right click, and create indicator. And it'll automatically insert a numerical indicator on your front panel. You can also right click, go to numeric, and insert an indicator and then connect it on the front panel. I find it easier to personally highlight it, right click, and then create the type you want to show. Now if I hit Run, it'll show the mean of this signal here. Now, the next thing we're going to want to do is be able to see two signals in LabView for this same waveform graph. To do that, we go into our DAQ assistant. Then we add in a second channel. And we're going to add a second voltage channel because that's what we're looking at. We're already using AI0, so let's select AI1. Click OK. And then hit OK again. It's going to have to build the DAQ this time again because of that. And then now we can hit Run, and we'll see two signals. The red signal is the second signal, and the white signal is the first signal, and it's plotting both on the same graph. But we're getting the mean for only the first signal. If we want to get the mean for both signals, then we have to use something called the split signal function, which is when you right click on the desktop or on the block diagram, you go to Express, go to Signal Manipulation, and then go to split signals. So what split signal does is when you have multiple channels in the DAQ, they all come out of this data file right here through this wire. So this blue wire has all 2 channels coming out of it. And if you selected 3 and 4, it would have all 4 coming out of it. Now, this is my split signal function. And if you go over it and highlight it, like you'll see this arrow here, the double up and down arrow. You just drag it down to how many you need. So if you need that many, you need 6, you drag it down to 6. If you need 2, you drag it down so you see 2. And I'm going to collect this left side, which means it's got all the signals I need. So this one's saying I have 2 signals and I want to split them. And then whatever comes out here is going to be each individual signal. This top signal is going to be the first channel. This bottom one is going to be the second channel. So I'm going to go ahead and just plot those so you can see that the split channel actually splits it. And I'm going to do that by right-clicking, creating new graph indicator. And then I'm going to do the same thing with the bottom channel. And I'm going to rename them Channel 1 and Channel 2, so that I don't forget what's going on. And then now if I hit run, we'll notice that I have the signal for 2 showing in 2 and the signal for 1 showing in 1. That's how you split signals. So again, when you have multiple channels from the same DAQ, you need to split the channels in order to do individual objects on them. So for channel 1 and channel 2. And also keep in mind that this blue wire connected directly to the DAQ has all the channels in it. So if you want to see both combined channels, then you hook a waveform graph directly to the data as we have here. So this is a combined graph. It shows both channel 1 and 2. And then if we want to see each individual channel, we split it using the split function, split block. Now, this mean is hooked up to this combined one, but I only want the mean of channel 1. So I'm going to delete this first wire. Then I'm going to come to this output signal, the first one for my first channel, and connect it in. And now when I hit run, it's going to give me the mean of channel 1 only. So the next thing we're interested in is now that we're able to collect data, we're able to collect multiple channels, we're able to make the mean, I want to save that. I want to save my data that I have collected. I want to be able to save the 2 channels, the information for the 2 channels, and I also want to be able to save the mean. But I'll start off by showing you how to save the 2 channels. To do that, right-click on your block diagram, go to Express, Output, Write Measurement File. Write to Measurement File, and you're going to insert that. And when you insert that, this little menu comes up. So here you can change the directory at which you want to save it. I'll change my directory to the desktop, but you can also specify a flash drive as well. And I'm just going to name it test. So now it changed to the desktop and test. I'm going to save one file. And then down here, if the file already exists, this is very important. If you hit rename existing file, then it's going to ask you the name of the file every time. If you use next available file name, the first time you run it will be test. The next time you run it will be test_1. And then the other important one is the overwrite file. If you use overwrite file, it means every time you hit run, it's just going to keep on replacing the data in the test. I like to use next available file name. That way I can have multiple runs and I can be able to keep track of which file is showing. The file format you want, you can dictate what type you want. Text LVM works fine. Section headers means how much y-axis do you want? Do you only want one header of y-axis data, or do you want one header per segment? What one header per segment means is that it'll determine a header for each channel, whereas one header only will only give you one header. And then you can also select no headers. Now you can specify what values, x values, that you want to have for time. So say you have 2 channels, you don't want to output a time value for each channel. You maybe only want to have one channel or one set of x values. And the way you can do that is one column only. What that means is that it's going to only show that first column of x values, and then next to it will be each channel's y values with respect to those x values. And the delimiter doesn't really matter. Comma and tabular, Excel will read either. So I'm just going to select tabular. Now there is a time where you may want to have the X values be one per column or one column per channel, which means that each channel will have its own set of X values, but most of the time you only want to have one column only. So then you hit OK. Now that the measurements file is finished, the right to measurements block is finished being inserted, we can connect the signals or what we want to save to this signals plot right here. And I'm just going to select the data coming directly out of the DAQ, which means that I'm going to save both channels' data as shown here in this waveform graph. So when I hit run, it's now going to create a text file, lvm.lvm file on the desktop. And if I hit run again, since I hit write or save as next available file name, you notice that it saves as text_1. Now to open these files in Excel, you just go to Excel or whatever you're using, open that up, then File, Open, and then you navigate to where you saved your files, and of course you change the file filtering to all files, and you just select it and hit Open. And then you just hit Finish because it already has it delimited and everything. And you notice this one has labels here for X values, and then voltage_0 and voltage_1. So this is channel 1 and this is channel 2. And this is telling you about how many channels are there, how long it took the collected samples, how many samples are there, what date it was, what type of units it is. And also at the top it tells you the date you did it and at what time it was ran. So you can now create a plot in Excel of your two channels of signal from using the X values here and the respective Y value for channel 1 here, and then X values here and respective Y values here for channel 2. Now, if I want to save my mean file, my mean value in my measurements file, I can do this. I can delete this wire, and I'm going to use something called a merge signal. So if I go to my functions palette, select express, and then go to signal manipulation again, select merge signals, and then insert it. Now I'm only trying to merge two signals, so I'm going to collect the merge side to my signal side, and if I'm merging more than two, I can select this and drag it down. I'm only doing two for right now, and you notice that I have a broken wire, so I'm just going to hit Control B to get rid of that. Now I'm going to connect the first channel to my actual data I'm collecting, and then I'm going to collect the second dot to the mean function output where my indicator is. And what this is going to do, it's going to save the data first for the graphs in the first three columns. For the X, first column would be X, the second column will be Y values for channel 1, third column Y values for channel 2, and then the fourth column is just going to be a single mean value. So if I hit run, it's going to be named as text_2, and I'm going to go ahead and go back into Excel and open that file. So I'm going to open it, and you notice it has my three columns for my signals and then my mean function. So going back into LabView, I have a pretty good idea of how I'm saving my data, but I don't have any real control over it. I can click run and then it'll save the data and it'll keep on saving it. Now what happens when you hit run continuously is every time it updates for a single collection of data, it's going to create a file. And as you notice, it did. So it created file text_3, 4, 5, 6. So this is where it's very important that you be careful not to have a bajillion files on your desktop. So I'm going to rearrange my front panel a little bit so I can get it more organized and be able to look at everything. I'm going to move my graphs to be all in one column, where my top graph is my combined signal graph and my bottom two are the individual signals. And then I have on my left my controls, and then I have my mean indicator. Now what I'm going to do is I'm going to create some controls for the right to measurements file so that I can dictate when to save, when not to save, where to save it, what file name was previously used, and an indicator to tell me if it is saving or not saving. That way I can tell what has happened. To do that, you can go over these little arrows and you can see what is there, or you can click on the block like you did for the DAQ assistant and drag it down. And what we're going to do is we're going to create controls for enable. So you're going to do that by hovering over enable, right-clicking, create control. And what this does is it gives us an enable or disable toggle button. When this button says disabled, like when I get this little finger arrow, I can click and hit disabled. That means that when I hit run now, another text file will not be written. As you can see, no new text file has been written. So now I can collect data and display it in LabView without having to have the file written every single time I hit run. Now the next control I'm going to make is something called file name. And what that means is I can control the name of the file before I hit run. So if I right click create control, I can now dictate directly where I like to save it and what name I would like to save it as before I hit the run button. So I can click in here and rename test to tests, hit enable, and then hit run. And once it's done running, it's going to show a text file on the desktop as tests. And then if I keep the file name the same and I keep on hitting run with the enable on, it'll rename the next file tests_1. And we see that here on the desktop. Now, I know what I'm naming the file. I know if I'm enabling or disabling it, but how do I know if it's really saving the data or what the last file name was? And I can create indicators for that. So if I go to file name out and right click, create indicator, I now have an indicator that tells me what the last file name was saved as. So now not only can I dictate exactly where I want each file to go, I can also find out what the previous run file name was. So if I hit run now, my next file name would be test_2 because test has been used, test_1 has been used. So test_2 is the next one. And that's right, it tells you that the last run was named as text_2. This is helpful in the fact that you can find out what file was just saved and be able to rename it or be able to dictate which file belongs to which. Now the very last thing that's of interest in this write to measurements file is if you're going to saving data, right click it, create indicator. What this will do is create a little LED that will light up if you save data and not light up if you're not saving data. So if I move that to the top next to enable, and then I hit run, you notice that the light's green saying I'm saving data. If I go over here to my enable button and uncheck it to disable and hit run, you notice that the light will turn off saying that I didn't save anything, and you notice that test_3 was not renamed to the test_4 because I did not save any files. Now the last two functions that we're interested in is creating a formula block, using the formula block, and also using the histogram. I will show you how to use the histogram next, and we're going to create a histogram of channel 1. To do that, you right click on the block diagram, you go to mathematics, go to probabilities and statistics, and then go to histogram. Click it and drop it in. Now I'm going to connect this very top one that says X to channel 1. And then this intervals, that's just telling you how many intervals you'd like to collect the data and display the histogram for. It's defaulted to 10, but you can create a control for it by right-clicking, create control, and you notice that it shows up on my front panel as intervals. I'm going to move that down with my controls for my DAQ. So I have my file information up here, my DAQ control, and my mean for my channel 1. And then now I want to plot that histogram. So I'm going to go to the right side to the purple at the top where it says histogram, right click, create indicator. And then we notice that at the bottom here it created a histogram graph. So if I hit run, it's going to create a histogram based on channel 1, and I'm collecting 1,000 samples, and you can see here that my counts on the vertical axis add up to 1,000. Now, I can change that interval to increase and decrease the number of intervals. So say I want 100 intervals, and then I hit run again. You notice that I changed the y-axis. Now if I hit maybe 5 instead of 100, the x-axis has remained the same, and I haven't had any changes because the signal hasn't been changing. But you can change the intervals of which the histogram is made. Now if I want to save this histogram file for later in my right to measurements file all into one file and not have multiple files, I drag my merge signal to add in 2 more because I need to have the h of x values and the x values. So I'm going to put my x values as my next channel going into my right to measurements file. And I'm going to make my h of x values as my last channel. And then I'm going to enable my save file. I'm going to hit run. And it's going to show up as test4. And now if I open this in Excel, I will see that it's added the histogram after the mean function. So my first 3 columns are my channel information I wanted. The next column is my mean of the first channel. And then the next 2 columns is my x values followed by my counts for my histogram. So I only shows the interval of 5, so it's only showing 5 data points, or 5 points of data. And then it shows the counts in the next column. Now going back into LabView, the last thing I'd like to go over today is how to create a formula in LabView. To do that, it's very simple. You right-click on the function blocks, right-click to get your function panel up, go to Express, Arithmetic, and Comparison, then select Formula, and insert it. And the way the formula works is x1, 2, 3, 4, 5, 6, 7, 8 is kind of like variables, and you can say I want to input these values. Then this double star is your exponent, so that you know that's your exponent to your exponential. This little block will show green if you have the correct number of parentheses and the formula is all correct. So right now what I'm going to do is I'm going to say x1 times x2 squared. And I'm going to put in the formula. This is just any random formula. You can insert something else, such as x1 squared to the 4th, and you can even rename this x1 to whatever you'd like. So I'm going to rename x1 to maybe velocity. And then I'll name it inside the formula itself. So you can name it to whatever you want. I'm going to put it back to x1. You hit OK. The output of the result of the formula is result. So I'm going to right-click and create indicator so I can see that result. And it's shown here as labeled result. I'm going to move that below my mean so I can have it more organized. And then now I need to put the inputs of my variables. And my variables for x1 and x2 are just my mean from channel 1. So I'm going to go ahead and connect that in. Now you can also have this as constants and other things, like I'm going to say I add in, you add a constant x3 into it. And if I go to x3 and hover over the little triangle, right-click, create constant, I can now type in a constant value of, let's say, 100. You can also create a control for this function to do the same thing as the constant does by being able to input and change the value on the front panel, and the formula will automatically correct for that. Now, the last thing I want to do for this formula block is be able to save that result. And I'm going to create one more merge for that, expand it one more time, hover over the result, and connect it to that merge. And then now I'm going to run it and get my result. So I see my result here, I see my mean here, I have my channels, both channels showing individually, my histogram, and then it told me it just saved this as test_5. So I'm going to go ahead and go to Excel and open test_5. And you notice that the first 3 columns again are channel 1 and 2 x and y values. Then the 4th column is our mean. The The fifth and sixth column is our X and Y values for the histogram. And the very last column is our function result. So that is it for today's LabView tutorial. You can go ahead and save this file for future reference. And I'm going to still save it again for previous version. And I'm going to save it for version 8.0. And I'm going to rename it. I'm going to replace it for my VI file. I'm going to resave it. Now I'm going to save it on the desktop this time. That way I can open this on any computer. And then after that, you just close LabView, and I hit don't save because I already saved it. And then this window comes up, and you can close it out, and then you close out of LabView.